Hello, I'm going to do three short videos with examples. I was trying to do one video with all three and I kept messing up. So here, we're going to do this two-step process, finding the eigenvalues and then the eigenvectors for some matrices. In this first example, the matrix is 1, 2, 0, 3. These are all going to be of the form 1, 2, something, 3. Okay. So we want to find the eigenvalues first. So step one, what is A minus lambda I? Okay, well, first is going to be 1, 2, 0, 3 minus lambda times 1, 0, 0, 1, which is going to be 1, 2, 0, 3 minus lambda times this matrix is multiplying each of these entries by lambda. That's lambda, 0, 0, lambda. And so I get 1 minus lambda, 2, 0, 3 minus lambda. So I've gone through this slowly here, but from now on, we're going to be subtracting lambda times I pretty quickly. To subtract lambda times I just subtract lambda from each of the diagonal entries. Okay, so now what is the determinant of A minus lambda I? It's going to be the determinant of the matrix 1 minus lambda, 2, 0, 3 minus lambda. And then I'll do the A times B minus C times D. I get 1 minus lambda times 3 minus lambda minus 2 times 0. And I'm going to set that equal to 0. That's the characteristic equation. So this was just, these two equals are just how to compute determinant A minus lambda I. And then what do I, and that's the result. Actually, it's not quite simplified. But setting it to 0 is a characteristic equation. So I get 1 minus lambda times 3 minus lambda equals 0. That's already factored. So the first solution is lambda 1 is 1. And the second solution is lambda 2 equals 3. Or if you want, you could say lambda 1 is 3, and lambda 2 is 1. So there's two possible correct answers to this problem, for the eigenvalues at least. This has eigenvalues, lambda 1 is 1, and lambda 2 is 3. All right. So let's now go to step 2. And all that stuff with the determinant actually doesn't really help us. We want to start, we really kind of start fresh with step 2. That's why I say for each of the lambdas. All right. So now we're talking about step 2. Okay. Here we have for lambda 1, which is 1. Okay. Here we have A minus lambda 1I is just going to be A minus I. I'm going to subtract 1 from the entries. I get 1 minus 1, 2, 0, 3 minus 1, 0, 2, 0, 2. Now, it doesn't always happen that the two rows are multiples of each other, but it does always happen that the determinant of this matrix is 0. So when you do this, you might want to check that the determinant is 0. Indeed, 0 times 2 minus 2 times 0 is 0 minus 0 is indeed 0. So now let's solve the let's let V1 be, let's just give the components names A and B. Okay? Then A minus lambda 1I, V1 equals 0 is, what is it? It's 0, 2, 0, 2 times AB is 0, 0. So there's A minus lambda 1I, there's V. okay? Or those two equations are 0 times A plus 2 times B is 0, and 0 times A plus 2 times B is 0. So this one I don't need, that's redundant. This is just saying that 2B is 0 or B is 0. So B is 0, but wait a minute, what's A? Well, A could be anything. There's no equation for A. So A could be anything except for 0. So we'll choose, so B equals 0, and we'll choose A equals 1 and get V1 to be 1, 0. Okay? Or you can say V1 is negative 42, 0. You want to be a wise guy. So even though there's only 2 possible correct answers for the eigenvalues, depending on which you call lambda 1, which you call lambda 2, everybody in the world could have a different answer for the eigenvector. They just get in line. The first guy gets to call his eigenvector, that's me, 1, 0. The second guy in line will say, oh, my eigenvector is 2, 0. Third guy said, my eigenvector is 3, 0. Everybody in the world has a different eigenvector, okay? And then some wise guy says, well, I'll make it 0, 0. That's the only, that doesn't work, right? Because 0, 0 cannot be an eigenvector. All right, so let's do the next one. For lambda 2 is 3, we have A minus lambda 2I is 1 minus 3, 2, 0, 3 minus 3. So this is going to be minus 2, 2, 0, 0. So indeed, this second row is a multiple of the first one. It's 0 times the first one, right? So again, we'll let V2 be AB and try to find the equations for A and B. And then A minus lambda 2I V2 equals 0 is, let's write it underneath it, negative 2, 0, negative 2, 2, 0, 0, AB equals 0, 0. Right? Or those two equations are negative 2A plus 2B equals 0, and 0 times A plus 0 times B equals 0. Well, that's just 0 equals 0. That tells us nothing. But this one says that 2A equals 2B, or better yet, A is B. So A can be anything. So, but I'll choose, except for 0, I'll just choose it 1, 1. That's probably the simplest one. Now, one of your Weber problems actually wants unit eigenvectors. The unit eigenvectors are, let's call it U for unit vector. U1 is 1, 0. Or I could take U1 is negative 1, 0. There's only 2 unit vectors with eigenvalue 1. And then the other one, for V2, I get unit vector U2 is 1 over square root of 2, 1 over square root of 2. Okay? Or possibly negative that same thing. Okay? All right.